Alright, so let's look at section 4.3. This is in your note booklet. Now we're getting into trig ratios. So in Math 10, we learned about the trig ratios of right triangles, and we learned SOHCAHTOA. Now, we're still using SOHCAHTOA, but now we're using SOHCAHTOA with respect to a unit circle and a coordinate grid. So when we're talking about a coordinate grid, I mean I have your x's and your y's. So let's look at this. If the angle that I'm talking about is right here, my reference angle, I'm calling that theta, that means that opposite of theta would be the y side of the triangle. So I'm going to call the y the opposite and the x the adjacent. Now since the unit circle, the hypotenuse is 1. So just looking at our opposite, adjacent, and hypotenuse. Now, instead of doing SOHCAHTOA, you could say that that means that sine is y over r, because opposite is y, and hypotenuse is r. So you could say that sine is y over r, or that cos is x over r, or that tan is y over x. So that's where the Sir-Kick-Sir-Ticks acronym comes in. But I don't think that's something new we need to store in our brains. I think we can just think of this as opposite, adjacent, and hypotenuse, and just dealing with the same thing we've always done. So let's look at, first of all, sine then. Sine is, again, opposite over hypotenuse. So let's just make sure we put that in there. Opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tan is opposite over adjacent. And this just relates, again, to the y and the x and the 1 in your unit circle. Are there any questions about how the y and the x and the 1 are related to the opposite, adjacent, and hypotenuse? Now, to go with our primary ratios, so our primary ratios are sine, cos, and tan. We also have what are called the reciprocal ratios. The reciprocal ratios are cosecant, secant, and cotan. So the reciprocal, remember, means the flipped fraction. So if sine is opposite over hypotenuse, that means cosecant, it's reciprocal, it's hypotenuse over opposite. So it flips your ratio. Again, if sine is y over 1, then cosecant is 1 over y. So it just flips your fraction. The reciprocal of cosine is called secant. So secant is the hypotenuse over the adjacent. And then cotan is the reciprocal of tan, and that is the adjacent over the opposite. So we're just flipping the ratio to come up with their reciprocals. Okay, so also remember from earlier that we had x squared plus y squared equals r squared was the equation of a circle. So first we're going to draw a diagram and determine the values of the 6 trig ratios for an angle that have the following points on the coterminal side of an angle. What the heck that means is that we have just a point. This point is on a circle, okay? It's not necessarily on the unit circle, but I need to use that to find sine, cos, tan, cosecant, secant, and cotan. Always, always, always draw it first. So here we have -4 and 3 would be somewhere over here. And if I make that into a triangle, I would make it into a triangle by connecting it to the origin and then going down to the nearest x-axis. The reason it's to the nearest x-axis is because these are all reference triangles, so they all have to include a reference angle. Okay, and remember reference angles are always to the nearest x-axis. Let's also label this. So here my x value is -4 and my y value is +3. I don't know the radius. How can you find the radius?
Plug it in.
Plug it in. X squared plus y squared equals r squared. So I'm just going to plug in -4, square it, add that to 3, squared, and that's going to equal r squared. So this is 16 plus 9 equals r squared. So 25 equals r squared. So 5 equals r. Also remember that your radius is always positive. So this is just a +5 in for my hypotenuse, or for the radius here. Once we're at that, then we can calculate sine, cos, tan, cosecant, secant, and cotan. The angle we're looking at here, again, is the reference angle. So let's start with sine. Sine of theta, which is that reference angle, is the opposite, so 3 over the hypotenuse, so 5. So sine theta is 3 over 5. Then we'll go to cos theta. Cos is adjacent over hypotenuse. Here the adjacent is minus 4, and the hypotenuse is 5. So minus 4 over 5. Tan is opposite over adjacent. So opposite is 3. Adjacent is minus 4. Now we can also find their reciprocals. So the reciprocal of sine is cosecant, which means the 3/5 is flipped to the 5/3. Cosine, the reciprocal of that is secant. Secant, when I flip the minus 4 and the positive 5, we get 5 over minus 4. So again, I'm just flipping the fraction for the reciprocal. The reciprocal of tan is cotan. So cotan would be minus 4 over 3 when I flip that fraction. So that's my answer. Those are the 6 trig ratios that are at the point minus 4 and 3. Part B, here our point is at 2 and minus 6. So positive 2 is the x, minus 6 is the y, which means I'm looking at a point somewhere down here. Again, I draw my triangle to the origin and then put my point to the nearest x-axis. When we label it, the x is 2 and the y is minus 6. Again, the angle that we're looking at is here your reference angle. So again, I have the 2 legs, I need the hypotenuse. So we can go x squared plus y squared equals r squared. So 2 squared plus a minus 6 squared equals r squared. Now 2 squared is 4. Minus 6 squared is 36. And that equals r squared. So we get 40 is r squared. Now, 40, when I go to square root it, does not work out nicely, unfortunately. So we end up with the square root of 40 for r. Now 40 can be reduced, so you do have to reduce your roots, just like we did in Pre-Calc 20. You have to reduce your roots as much as possible. So remember that to reduce this root, you see if there's a perfect square that can go into it. So I know that 40 is 4 times 10, and 4 is a perfect square. Now I can square root the 4. When I square root the 4, it comes out as a 2. But the root 10 doesn't root, so it stays underneath. So that means that 2 root 10 is the radius here. 2 root 10 for my radius. So that was how we simplified roots in Pre-Calc 20. Now we can go through and do sine, cos, tan, and their reciprocals with that information. So let's start with sine. Sine is opposite over hypotenuse. This is minus 6 over 2 root 10. What's the problem here? Can't have a root in the denominator, right? How do you get the root out? Multiply. So I'm just going to multiply top and bottom by the root 10. So we're going to get minus 6 root 10 over 20, because root 10 times root 10 is going to be 10, multiplied by the 2 will give me 20. Now this still isn't quite right, because I see that I have 6 and 20, which are both divisible by 2. So when I divide out by 2, I'm getting minus 3 root 10 over 10. And that would be your answer for sine. Okay, so for cosine, cos is going to be adjacent over hypotenuse. So this is going to be 2 over 2 root 10. This time I'm going to simplify it first, just to show you the other option. So here I have a 2 divided by a 2, which is really like a 1 over root 10 if I divide out my 2's. Now I can get the root 10 off the bottom by multiplying it out. And when I multiply it out, I get root 10 over 10. Because 10 times 10 is 100, and the square root of 100 is 10. So that would be for cos.
I really don't understand how you...
Alright, tan should be easy here. Because tan is opposite over adjacent, so minus 6 over 2 is just minus 3. So that one's a nice easy one for us. Or minus 3 over 1. Now our reciprocals can actually be made fairly easy. Let's look at, first of all, cosecant. So cosecant is the reciprocal of sine. You guys, you should take it from the very original one, because when you flip it, then this root is on top. If you go to the last one, then you have to rationalize everything again, so it's kind of ugly. So let's go to the first one. When I flip this, I get 2 root 10 over minus 6. And then all I have to do is simplify my 2 and my 6. So I just get root 10 over minus 3. So that should work out nicer for us. Then we take secant. Secant is the flip of cosine. So again, I'm going to take it from the start of cosine. So we get 2 root 10 over 2. Divide out those 2's, so I just get root 10. And then tan, the reciprocal is cotan. So cotan, when I flip tan, and here I can go to the very last one because there's no roots. So I get minus 1 over 3 when I flip minus 3 over 1. So we're just making the reciprocal of each of those fractions. Okay, so let's then just remember that in grade 11 we learned that we have a smart trig class. A smart trig class means that all are positive in quadrant 1, only sine is positive in quadrant 2, tan is positive in quadrant 3, and cosine is positive in quadrant 4. So that was our little rule from pre-calc 20. Now what we will do then is let's look at applying that to our next example. So example 2 says if theta is in the indicated quadrant and has the value indicated, find the rest of its primary trig functions. So I'm told that sine of negative root 11 over 4 is in quadrant 4. So that means that my triangle is somewhere down here. Always draw your triangle first. Now if this is sine, that means we're dealing with the opposite over the hypotenuse. So I'm going to put these values in. So again, remember your angle would be here. The opposite would be the root 11. The hypotenuse would be the 4. Now which one of these would be negative? Because I see it's a negative here. Would it be the root 11 or the 4? The root 11 would be negative, right? Because these y values are in the negatives. The radius is never negative. So then we're going to go and we're going to find our missing side length before we find cos and tan. So once we've found that x is root 5 by our x squared plus y squared equals r squared, then we can go ahead and find the rest of our values. So we know sine, we need cosine. So cosine for my angle is adjacent over hypotenuse. So here adjacent is root 5 and hypotenuse is 4. So cos is root 5 over 4. Then we can look at tan. Tan is opposite, which is minus root 11, over adjacent, which is root 5. But I see a little problem here. We have a root in the denominator. Can't have that. So let's multiply top and bottom by that root 5. So on the top, we'll have 11 times 5 is 55 under the root. And on the bottom, 5 times 5 is 25. But when I root that, I just get 5. So tan is going to equal negative root 55 over 5. Now the other thing you just need to check is that it followed our A smart trig class. And according to that, cos should have been the only thing positive. So when I look here, sine was negative, cos was positive, tan was negative. So it fits with the rule that we were given. A smart trig